Hi guys, I'm Rahul Baluri and I'm the event captain for Hydrogeology, and today I'm just going to be going over what the event is to begin with, how to get started, and yeah, pretty much those. So let's get started. So to start off, what exactly is hydrogeology? Um, it's the study of groundwater, water coming from the hydro part of the name, and geology coming from earth science coming from the geology part of the name. So what you'll find kind of interesting about hydrogeology is that it kind of shares a lot of aspects that other earth science events do, in the fact that it shares the same basic foundation, but obviously it's a lot different in that it focuses on groundwater. So um, there are a couple test components. One part of the test is written, and the other part of the test is a computer simulation. So I'm going to be going over that on the next slide, discussing the parameters. So um, the test as a whole is 50 minutes, and the written part of the test, part one, is approximately 25%. The next part is the groundwater simulation, which actually takes place on a computer, which is kind of interesting. That's worth about a quarter of the total percent as well. And lastly, the last part of the test is again a written test, but it's kind of building off of the information, the data that you collected in part two. So that's worth the majority of the percent. It's 50% of the total grade. And you can bring a couple tools to the test. You can bring a calculator and a protractor for the hydrogeology challenge, which is again the groundwater simulation. And I'll definitely discuss what that challenge is to begin with later on. In addition, you can also bring a double-sided page of notes, but it's recommended that you don't just copy and paste everything onto the notes. It's better to just familiarize yourself with all the material and then put the stuff that you have the most trouble with onto the notes. So it'll be a lot easier to search for things. And in addition, I kind of discussed this in the previous slide, but it's a partner event, meaning that you're going to have to. It's really in your favor to split up the time and the activities between you and your partner, especially considering one part is on paper, the other part's on the computer, which means you're going to be saving a lot more time. And yeah, and in addition, if you want to a more detailed look at what the parameters of the event are, you can of course go to the resource folder, and there's a PDF that pretty much goes over lots of things that I just mentioned, but in a much more detailed manner. So definitely check that out. Okay, so in terms of the content, the first part is the groundwater challenge that I'll be discussing. So if you head over to the website, which is groundwater.behere.net, or you can just go groundwater.net, I think is the title of the website. This is pretty much, you're definitely going to be wanting to know what how this this works, and it's loaded up here. So this is a practice exam. Basically, all you have to do is select a couple wells, and what this the hydrogeology challenge simulates is groundwater flow between these three wells. Based off of the table, the information that each well has, like such as its water table elevation, marked by the S. You can calculate the flow direction and the horizontal velocity and a lot of other things. So what's really good about these practice exams is it actually walks you through all the steps. You can check your answers and show your solutions, so you can get familiarized with the process. But obviously on the real test, you're not going to be you're not going to have access to all these checking answers and whatnot. So yeah, definitely get to know how this process works. So there are also a couple contaminants that you're going to be wanting to know for the test. And actually, there's a contaminant table, which I believe is located in the resource folder. If not, I'll definitely put it in there. But basically, this pretty much lists a huge amount of contaminants of groundwater that you're going to be wanting to know about. So there are a lot of different categories, whether that be volatile organic compounds or you know, inorganics. There are all kinds of categories in here, as you can see, but it does seem kind of a little overwhelming. There's like such a big variety of contaminants. But the good thing is that if you scroll all the way down, it actually says which specific contaminants and parts you're actually going to be needing to memorize for each of your tournaments. So don't feel too, I guess, overwhelmed by the size of this chart, but you should also, you know, you should still know, I guess, the majority of, or a good amount of the chart. And in addition, some of these problems are actually in relation to the groundwater challenge, which basically means that, um, for example, let's say based off of the water table elevations, for example, well C has a bigger elevation, of 2,591 feet compared to, well D, 2,507. So, they might ask you whether, if well C is contaminated with, a certain contamination or pollutants, which wells would it flow to? So obviously, it would flow downwards from higher elevation to lower elevation. So pretty much problems in relation to the groundwater challenge. And you're also going to be wanting to know a couple of remediation techniques. There are a lot of techniques that you want to be knowing. Whether that be phytoremediation, essentially. So basically, what remediation techniques are to begin with. Let's back up for a second. I guess it's essentially if groundwater is contaminated, it's pretty much removing those contaminants. So there are a lot of different ways to, I guess, get rid of contaminants. They could be chemical or they could be physical, biological, and what actually, the final part of the test is typically a remediation table. So, basically what you're going to have to be doing is filling out a chart that lists a bunch of, a couple selected, remediation techniques, and you're going to have to be determining the cost and a couple other aspects of them. So yeah, there are definitely a lot of techniques that you're going to be wanting to know, and and of course you're also going to be wanting to know a lot more, a lot of other vocabulary words. What's pretty good is let's see here. So on the it's groundwater.org, which is the website, and which has the Hydrogeology Challenge, and they actually have a pretty good, glossary of a bunch of different words that you're going to be, that are really important to understanding hydrogeology. The good thing is, though, that, I think like one of the most important things to do with this kind of, such a big list of vocabulary is not to just kind of memorize these, but actually what I did is I pretty much put them into a document and I pretty much reworded all of the words that I didn't know. And I put pictures to kind of get a more visual representation of what each word is, and it kind of made me, understand, I guess, what each word is to begin with. So yeah, you're definitely going to be wanting to know about, oh, by the way, here's a picture again of the Hydrogeology Challenge. And you're going to be wanting to know about, if you see an image like this, you're going to be wanting to, I guess, recognize and distinguish each part. There are a lot of different types of aquifers, like confined and unconfined. The water table, and there's a lot of different aspects. So get to know those. And karst topography, which is basically when acidic groundwater affects rocks under the surface and creates different landscapes like caves or sinkholes. So yeah, there's a lot of different aspects, and I guess too much to talk about in such in a short podcast like this. But yeah, and this is just another picture of a remediation technique. This is granular activated carbon. So yeah, it's just pretty much another example. Okay, so let's go over a sample problem of I guess the hydrogeology challenge. It's I'm only going to be going over a really short part, but yeah. So these are like essentially the real calculations that you're going to be receiving. Um, the calculation problems. So as you can see here, um, we have a couple wells that you probably saw just appear just like in the on the groundwater.org hydrogeology challenge. There are of course 3 wells. You can ignore the pumping part because all the conditions are going to be considered to be static. Basically, there's no additional pumping of the water, and yeah, you're going to be wanting to focus on the water table elevation, which is the S value. And basically, what this is asking is between wells D and B, there's a point where the elevation of the water table is exactly the same as the elevation of point E, and how far away from B is this point? So basically, the point that we're looking at is between D and B, and we're looking at point E right here. So yeah, the point would be right here in relation to well E, which is right there. So yeah, we're trying to figure out the distance from well E to that point. So we know that we know all the elevations of each of the wells. So 1,427 feet for E, 1,428 for D, and 1,418 for B. So we're trying to figure out. I'm sorry. How far away from B is this point? Excuse me. Okay, so it'd be essentially this distance, and we know that the elevation. If we subtract the elevation of B from the elevation of E, we'd get about 9 feet, and if we subtract the elevation of D, the difference between these 2 wells is 10 feet. And we know that this elevation between B and D is 25,214 feet. So if we multiply the ratio of this difference, and this difference with this value, then we can find this value, which is, I guess, it would be 0.9 times this value, which is 22,693 feet. And then the second part is drawing a line indicating the flow direction, and basically it would be perpendicular to, I believe, to like the direction of the flow. So it'd be, I think, approximately northwest of a line, indicating that's the flow direction. And the last problem is you have to find the flow speed if the conductivity is 241.2 feet per day and the porosity is 0.32. So basically, in order to do this, you're going to be needing the equation V equals Ki over N, which is it's essential for the hydrogeology challenge. If I just go over to the SciOly.org wiki, just for example, they have the equation V equals Ki over N. V is referring to the velocity. In other words, the flow speed that we're trying to find out. And K is 241.2, and the porosity is 0.32. So essentially, it's obviously a little hard to go through it right now, but during the hydrogeology challenge, you're going to be finding out the I value, which is essentially the horizontal horizontal gradient of the aquifer. So you can plug in those values, and it'd be V equals Ki over N. In other words, it'd be 241.2 feet times the I value over 0.32, and you're going to be getting your flow speed. So yeah, if we head over back to the PowerPoint, so there are a couple of resources that you're definitely going to be wanting to take advantage of. Some of which are in the resource folder. Obviously, it's a little sparse at the moment, but as the year progresses, it'll get a lot more filled. So there are a couple resources that you're going to be wanting to know. First of all, there's the hydrogeology textbook, and I just want to say that's a really big textbook. It's 477 pages, which is not exactly entirely beneficial because there's a lot of information, and of course, not all of it's actually going to be showing up on the test. A lot of information is kind of can be useful, but a lot of it's also a little superfluous. So I wouldn't recommend using this as your primary source of studying, only because there's just way too much here to handle, and I think doing your own research is a lot more beneficial for you. So yeah, I think if you want to get I guess a good idea of I guess like an introduction to hydrogeology, you can go ahead and go over to read the introduction part. You can skim parts, but I wouldn't I guess, but it's still a pretty helpful resource to start off. And in addition, there are plenty of YouTube videos. Actually, if you go to here, I have a helpful links document which has a lot of helpful links. But yeah, there are a lot of video walkthroughs that you can watch. Actually, the official Groundwater Foundation, yeah, they have like a walkthrough of the Hydrogeology Challenge, which is really helpful. They have a couple like workshop explaining things, so that kind of gives a better idea, of the challenge. And of course, yeah, there's like a lot of other links that you can find on the internet. Obviously, it's like introductory links. So yeah, and of course, over the course of the year, we're going to be getting a lot more practice tests that you can be working with. I think these are one of the best ways to actually master the material, because studying is one thing, but actually applying it to a test is another. Being in a testing kind of environment, and yeah, you're going to get a bit better idea of what kind of problems you're actually be seeing specifically. So I think, yeah, practice tests are definitely, excuse me, yeah, a great resource. And yeah, this is a really helpful PDF that I found on the official SciOly website. It's like an event guide, and it pretty much goes over lots of the things that I talked about, but in, I guess, more or less, I guess, detailed. There are also a couple sample tests and practice problems along with each part, that it explains. Yeah, there are a lot of sample tests as you scroll through. So this is definitely really helpful because it kind of gives a really good idea of what components the test actually has. So yeah, you should definitely look at this. And yeah, I guess that's pretty much it for. That's all I have to say as an introduction to hydrogeology. I mean, it's obviously a lot more. There's a lot more to the event than what I just talked about right now, but as it stands, that's pretty much all I have to say for now. So yeah, sorry about the fact that this isn't a live recording. There were some audio problems with my first stream, so with my first video cast, so I decided to make a recording. But you can still feel free to ask me questions. Of course, you can talk to me at the meetings, and here's my email on top of the screen. It's upalurirahul@gmail.com. So yeah, feel free to ask questions, and yeah, thank you for watching.